Fix this thing. There we go. Oh. Good morning, the two of you. I don't know who you are, but good morning. We'll wait till everybody else come. We shouldn't be on that long today. But test's going to be tomorrow. Good morning. Oh, so sister number one, how you doing? Man, I miss you. Oh, Marky Mark. Good morning, Jamar. Oh, really? Well, Jamar, I don't talk to you a lot in class, man. You're always quiet. Because you can have your nickname is lunch, breakfast, because you eat it literally in my class every morning. Actually, Jamar, this is more I've communicated with you the whole semester. Besides, make sure you eat. I want you to have a stomach. I want you hungry while I'm teaching. Okay. All right. So we're going to go ahead and get started. All right. So we'll go ahead and get started. So I gave you some odd problems. I posted the answers last night. We're going to go over that. And I'll put on the blog. We're gonna take another quiz, and I'm gonna grade those quizzes today. Because I gave y'all a quiz. I gave my AP stats. I gave them a test. So I'm gonna grade all that today because I taught 3 classes yesterday. So I actually wasn't done at like 5:30 yesterday. So I was on the computers from like 10 to 5:30. All right, so I grade that stuff today. So any question you have on the odd one. So, because today after we're done, I need you to go back and do the even problems. We'll talk about that tomorrow, and I'll tell you what the quiz is about in the blog. Okay, and then we'll take the test after we go over the odd problems, and I'll post that test tomorrow. Then you can turn that in, get all that graded. Then the next thing we'll do, so that's tomorrow. So Friday, we need to take a midterm. So what the midterm is, we'll replace some of these low grades that some of you have. Not all of you, but we still have to take the midterm. And I think that's 10% of your grade. Okay, so what we're gonna do is 4 units, but you only have to do 3 of them. That's it. Okay, so if you get and that'll be your midterm grade because everybody has to give a midterm. Now, if you was in an accelerated AP Stat class or AP Calc class, we don't do midterms because we're trying to get ready for the national tests. But for regular classes, for one semester class, we have to give the midterm. All right, so I put the answers to the odd problems on the blog. But what questions do you have from those odd problems? Then I can work those, and then we'll be done. Then I need you to do the even ones for tonight, and I put again out evens and what's going to be on the quiz tomorrow. I put all that on the blog. 5, 7, or 9, 5 and 7, 5 and 7 or 9. Okay, cool. All right. Okay, we'll talk about that. All right. What else we got? Drink on my coffee. Oh, 21. Okay. So you're gonna, before we do these problemts, let me show you something. Okay, let's say if I had 3x plus 1 is greater than, say, 2. Or, yeah, we could do 2. All right, let me see. No, let's do 7. And we're gonna put a negative here. All right, so you always want to try to keep your variables positive. Now, normally I can take this is an example. And that probably help you with 9. Okay, so if I had to work this problem out, I would subtract 1. So that'd be a negative 3x. Negative 3x is greater than 6, right? All right, so if I was to divide this by negative 3, divide this by negative 3, so this would change to negative 2, right? So I start off, this was a positive. I divided by a negative, this is negative. Start. This is my start. So if I divide a negative by a negative, that's going to give me a positive. So that's x. So I change the sign of each number. But since I divide by negative, I have to change the inequality as well. Everything has to be changed. Now, say to yourself, well, again, why don't you flip it? Okay, so now I'm going to come over here and work it out again. And you want to keep the variable positive. So if I want to keep my variable positive, I'm going to add 3x to both sides. Cross that out. So I have 1 is greater than 7 plus 3x. All right, I need to isolate x, so I'm going to subtract 7. So that's going to give me a negative 6. Then I'm going to go here, 3x. X is less than negative 2. So I hope that helped you out. Because anytime you got inequality, you divide by a negative, you have a negative variable, you have to change the sign of literally everything. You got to change the sign of your numbers, and you also have to change the sign of your inequality. Now, instead of having to change the inequality, you can simply just work it where your variable is just be positive. Just make sure your variable is positive. You'll get the same thing, because this is x is less than negative 2. This is also x is less than negative 2. Cool. All right. So let's go back to these questions that you all have. Oh, before I forget, you have to take your electives. If you're a non-magnet student, Mrs. Hurley is going to take care of your electives in your schedule. You already know that. But if you're a non-magnet student, you have to apply for your electives. So I put on the blog it tell you about your electives, how to do it. Then the administrator, Ms. Stennis, just gave us a set of classes, all the classes available for you to sign your electives. So I posted that on the blog. So if you go there, say elective classes. So if you click on that, those are all the elective classes that's available. So make sure you look at that as well. All right, so let's keep it moving. All right, so number 5. Okay, we have a negative 4 to square root of. Okay, negative 2 minus x is equal to negative 4. All right, so what you want to do is divide both sides by negative 4. So that's going to leave you with negative 2 minus x. And that's going to give you a 1. So now we have to eliminate this radical. So this is imaginary 2. So this is the second root of the square root. So we have to get rid of the square root. So we're just going to multiply. We're going to square both sides. So now we have 1. This takes the radical off, because remember, this is your power. This is your root. And you're always going to do your power divided by your root. So 2 divided by 2 is 1. So you just left with a negative 2 minus x. Now, you can do this one or two ways. You can keep your variable positive. If I want to keep my variable positive, I'm going to move this over. So I have x1 plus x, a negative 2. Move this over. X is negative 3. Now, you always want to check to make sure this is not an extraneous solution. All right. So we'll put a question mark by that, because we got to go and check it. So what we want to do here is a negative 4, a negative 2 minus negative 3 equals to 1. So we have negative 4. Sorry. So this should be negative 4, because you got to go to the original problem. Okay, so that's going to give us a negative 2 plus 3 equals to a negative 4. Negative 4, 1. We know the square root of 1 is 1. So this checks. So that's your solution. That's 5. Okay, I know you saw these negatives, it's like, whoa, what are they talking about? Just work it out like you normally do. The stuff you've been doing since 7th grade. Just take your time. You know the basics. We just taking the basics and we just kicking it up a notch. Okay. It's called life. You always want to grow. All right now. All right, so I think we understand this one. So then we'll go ahead and do, if you go ahead and do start on 7. We're gonna do 7 and 9 since we only have 3 more problems to do. We'll do all these. Oh, somebody said 15. Okay, got you there, soul sister. Now, all right, so all right, so let's look at number 7. Okay. Oh well. Okay. So now what we're going to do, this is a root. Okay, number 12. Number 12. We told you to do the odd ones. Come on, Mark. Odd ones, man. The odd ones. We'll do 12 tonight. I'll do 12 tomorrow, I promise. Now, okay, so now what we want to do here, we want to square this. Well, we're going to put an equal sign. We'll come back and just do it. All right, so we're going to square both sides. So then that'll give us 64. Then this is taking a radical off, because remember, this is your second root. So pi divided by the root. So that's taking off the root. So we got a -1 minus 13x. So we're going to add 1. So we have -13x is equal to what? So what did I do? Oh, 65. So 65. All right, so then x is equal to a -5. All right, so since it's an inequality, we got to do, so x is going to be less than or equal to -5. But we got to check. So what we want to do, we're going to plug in -5. We've got to plug something less than -5. So what we're going to do, we're going to do -1 minus 13, -13 minus 5. Okay, is less than or equal to 8. So that's going to give us a -1. That's plus 65. Then less than or equal to 8. So that's going to be square root of 64 is less than or equal to 8. So that checks. Now we got to pick something less than this. So we're going to pick -6. So we have a -1 minus 13. Or is it greater than? Okay, all right, we'll check. We'll do both. Be on the safe side. So we got -6. Less than or equal to 8. So I think x is going to be greater than, because if we do, so I think this is less than. But we can check. So we can do here. So that's going to be, what number is that? That's number 7. So let's check this out. So this is going to be less than. So if I do this, this is a -1 plus, if I do 5, 13. So that's going to give me, so this is 60, so that's be 78, wouldn't it? Let's see, 13 times 6. Okay, that's 8, carry my 1. 78. Good. So it's 8. So that'll be 77. So this is going to be bigger than 8. So it's going to be X has to be X has to be greater than. So how we're going to do that, we can put in a number greater than 5. So that's going to be a -1 minus 13. Then we'll do a -4 and see if that's less than or equal to 8. All right, so that's going to give us a -1 and 13. So 13 times 2 is 26, right? So 26 times 2 is what, 52? So that's plus 52 is less than or equal to 8. So that's going to give us 51. And 51 is less than 64. So that checks. So X is greater than or equal to -5. Because we checked to see if it was less than, and we said this didn't work, right? So this works and this works. So therefore, X is greater than or equal to -5. All right. So we did this on a previous problem, previous lesson. I know you feel like we've been doing Unit 4 forever, okay? But Unit 5 is only 3 sections, but it's going to take us about 4 days to do it, though. So this is how you do number 7. Questions? If no questions, just say no. But again, when we did inequality, we did the number line. We got to check on either side of the value we get for 5. Okay. Good. Okay. All right. I'm going to go ahead and do 9. All right. So number 9, we have the square root of what's that? -1. And by the way, on-level algebra students not doing problems like this. If they're doing them, they're bonus. But like I said in class, we are not regular algebra 2 students. We are accelerated. So we got to give you the accelerated questions. Now, all right. So now we're going to come into inequality. So that means we have several answers. Okay. So now we got to get rid of this square root. So we're going to square both sides. All right. So that's a -1 minus 5r we'll do equal. Okay, so that's going to be 4. All right, so then if I was just me personally, what I do is try to make the variable positive. So I would just do -1 4 plus 5r. Ask where you coming down. Okay, now, so now we have, if I did this, and so that means R is going to be -1. So what I have to do now is I have to check on either side. All right. So since this is going to be greater than or equal to, I have to include 1. So I'm going to check and see if 1 works. 1 works. So I'm going to put a -1. Oh, we get ready to do it when they flip the sign. We get ready to do that. We get ready to do that now. Who is what at? Who is that? All right, now, so we have a -5r. Okay, is greater than or equal to 2. All right, so we're going to plug in -1 to see if it works. So we have -1 plus 5 is going to be 2. So the square root of 4 is greater than or equal to 2. That works. Now, we got to pick something on the left side and on the right side of this. So let's see to see which one we're going to be greater than or less than. So what we got to do, let's plug in 0. So we got -1 minus 5 times 0 is greater than or equal to 2. So that's going to be a -1 is greater than or equal to 2. So we know that's definitely not going to work. And so we know that 0 is greater than -1. So we know it should be R is less than. So how we'll come up here, we're going to check. So we're going to do something less than -1. So we're going to do -1, -5, -2 is greater than or equal to 2. So that's going to give us a -1 plus 10 is greater than 2. So that's the square root of 9. So the square root of 9 is greater than, because the square root of 9 is 3, right? So we know that 3 is going to be greater than 2. So -2 is less than -1. So this is going to be your answer. All right. So Marcus, I guess you just came in. So we're going to see why you flipped the sign. I'll show you in just a second. So this is how you find the answer. So we set it equal like we did in the previous lessons. Okay, we got x equals -1. But remember, we're on the number line. If we had -1, then we did here. Remember, we checked on this side, checked on the right and the left. So we checked on the right side. If it works, we just shade it this way. If it doesn't work, we do not shade it. Then we plug this in, plug an answer less than that. If that works, then that's what the shading is going to be. All right, so we had what? Negative. So this is the solution. So any value plug in for R that's going to be -1 or less, you're going to get a solution for it. All right. So Marcus, let me take care of you since you came a little late. All right. So we did 5. We just did 9. So we have 15 and 21 left, right? All right. So for you, Marcus, let's say if I had -3x plus 2, and I had a -4. Okay, so I can, if I work it out normally like you do here, 3x subtract 2, so that's greater than, so if I subtract 2, that's a -6. Then I divide by -3. All right, so this would change to a +2. This is changed to 1. This is going to be x, but you also have to change the inequality. And I'm going to show you why. So now I'm going to take the same problem. I'm going to do a -3x plus 2 is greater than a -4. So what I want to do is I want to keep my variable positive. So I'm going to get rid of this, then a +3x. So now I have 2 is greater than -4 plus 3x. So I'm going to move this over. So that'll give me +4. Get rid of this. 6 is greater than 3x. X is going to be, divide both sides. So x is going to be less than or equal to 2. So to remember at the end, you want your variable positive. So if I have a problem like this where my variable is negative, I'm gonna move it over so it can be, if I move it over where it's positive, then I just work out through the problem. It's gonna give me the answer. But if I keep this negative over here at the very end, I have to change the inequality as well, because this changed from a negative to a positive. This changed from a negative to a positive. Well, guess what? This inequality can't be left out. It has to be changed as well. All right. So we got 15 and 21 left. So I'm going to go ahead and erase this. If you plug, remember I showed you, look. So for number 9, you have the square root of -1 minus what 5r is greater than 2. Okay, so if we said we plug, so we got -1 and we have our x, right? So if we plug in -1, all right, so that's going to give us what, a -1 plus 5. Okay, it's greater than 2. So that's the square root of 4. So the square root of 4 is 2, right? So we know that's true. Now, this is -1. So we got to pick something on. So we know -1 works. So we know that works. So we got 0 and we got -2. So now remember from the previous section, we got to pick a number on either side, see which way we're going to shade. So let's say I plug in 0. So this is -1. So if I plug in 0, I got a -1 minus 5 times 0. Okay, it's greater than or equal to 2. Well, look here. A -1, the square root of -1, that's imaginary, man. That can't work. So we can't shade here because it's undefined, isn't it? Because this is imaginary. Now, if I plug on the other side to check to see which way I'm going to shade, now I'm going to plug in -2 here. So I got 1 minus 5, -2 is greater than or equal to 2. So that's going to give me a -1 plus 10 is greater than or equal to 2. Okay, so that will give me the square root of 9, which is 2. So the square root of 9 is 3. So 3 is greater than or equal to 2. And so that is for -2. So that means I have to shade this way because that's where the value is true. So that means that x is less than or equal to -1. Because remember, this is what? So if I come here, that's I is greater than or equal to 2. And that's imaginary, right? We can't have no imaginary solutions. Because actually, anything 0 and above is just going to give you an imaginary solution. If I plugged in 1 in here, that'll be -5. That's -6. All those answers are imaginary. Make sense now? You got them? Yes, no, maybe. All right. I'm going to go ahead and do number 15. So let's look at 15. Okay. All right. So 15. Whoa. All right. So for 15, before we graph this, we're going to do the parent function. And this is called your ceiling. No, not ceiling. This is your floor function. Or you could say is your I think it's your least integer function. No, it's your greatest. I'm sorry, it's your greatest. So it's your greatest integer function. So I'm going to graph. If you look in your lesson, it shows you how to graph that. So in other words, all your y values have to be integers. Okay, so if you graph this, it should look like this. 1, 2, 3, 2. Now I should notice, I hate looking back at notes. Okay. I consider myself an expert in my field. Now, okay, so I have 1, 2, -1, -2. All right, so that's 1, 2. So if you have what's called a floor function, it's also called, this is one of your step functions as well. Reason why they call it step function, because it look like steps when you're done. Okay, so if you're doing your ceiling, so if you're going to do at 0, so that means it has to be here. And then you got to go. So since this is 1, you're going to go each space by 1 in the x direction, each space by 1 in the y direction. All right. So what you want to do, you want to put an open circle here because you're looking for, so everything in between here has to be 0. Now you have to go up 1 because this is 1. So you're going to go up 1, you're going to open that up, and then you're going to close it here at 1. So everything in between 0 up to 1 has to equal to 1. All your values have to be integers. So now, since this is 1, you just will go up one more spot, open circle. The distance between the x's is 1. So you're going to close that. Then here, then you're going to go back. Close this. This is at -1. Go back to -2. Open it. So everything in between here, between greater than -2 up to -1 is equal to 1. That's your parent function. All right, now we're going to do this one. So this one, you're going to be, your space in your y direction is going to be there's 2. Since again, this is 1. All right. So we're going to do the same thing we're going to do here. Okay, but instead of, make sure I got this correct problem. Okay, so number 15. Oh, it's -1. My bad. I'm sorry. Then here, you're going to do x -1 equals 0 and x equals 1. So this part right here is going to be your shift in the x direction, which is going to be 1. So we're going to take this parent function. So we're going to take what this normally be from here to here. We're going to shift it here. Take this and we're going to shift it here because we got shifted by 1. And then since this is 2, this is the space in between these two is going to double. So we're still going by 1 because this is 1x. Then this is our shift. So we got to take this. We got to take this, move it over 1. Take this, move it over 1. But instead of distance between the two being 1, it's going to be 2. All right, so let's graph it. And this continues on. You can do this forever. But if you think about it, it's a step. Like going up some steps. That's why they call it step function. We could continue here. It's not just in this just little region here. You could just keep going on forever. You could keep going on forever in the negative direction. Okay. All right. So remember, we said we're going to shift. This is going to shift over 1. So now, instead of this being open at -1, now it's open at 0. And close that 1, because again, we got to shift this over 1. Now we'll go up here. We got to shift this over 1, but the distance between the two, instead of being 1, is now 2. So we're going to go, instead of going up to 1, we'll go up to 2. We're going to open it. Then we'll go over here, close it. Then we can just keep going. So we're going to go, instead of going up 1, since this is 2 here, that double, your y doubles. So we're going to go here, open it. No, sorry. It's going to be open here. Since the space is 1, we're just going over 1 in the 1 over 1 in x direction, close it, and we just keep going on. Now, if we want to go here, we're going to go down. Instead of space being 1 in the y direction, now it's 2. So we're going to close this, go back 1, open it. So all your y values has to be an integer. Now, if I want to keep going, I'm going to go and close at -1, open at -2. That's your step function. This is your pair function. This is what it looked like if you just had your floor or your greatest integer function. If you think about it, the reason why I call it greatest integer, because when whatever value you're looking for x is 0 is going to be your greatest integer, because that's just the highest number it can be. Then you just drop back 1. So in between there, it's going to be, that's what your value is going to be. So that's your parent function. Now, this is going to be your shift. So you have a vertical stretch. You have a shift to 1 in the to the right in the x direction. This does not change. Okay. Questions? I know I'm just writing a lot, but I'm trying to make sure that there's nothing that you do not understand. Now, I'm not expecting you to write all this here on the board. Okay, all I want is this graph. But I want to make sure that everybody understand exactly what this means. Because the reason why I say that, because when you take your high-level math classes, you're going to have graphic calculators, again, like I said in class, that's going to do this for you. But you need to know where it comes from. Because this right here is going to reason why you're going to do your job. So if you can, for your math, it's teach you how to think, critical think. Okay. You have to know the process. In any job, successful job you have to be able to think, and you have to know the process. All right. So I'm going to move on to number 21 so we can be done for the day. All right. Please make sure you look at your blog this afternoon to see what's on the horizon for tomorrow and the rest of the week. All right. So let's look at 21. Oh, so 21, again, you're going to see this a lot in your calc and your pre-calc classes. It's called your piecewise functions. So in other words, no, it would not be longer in the x direction, because when you did 15, it was what? F of x is equal to 2x minus 1. All right, so this right here is going to tell you how long in the x direction. This is going to tell you how long in the y direction. Then x minus 1, say the x minus 1, that's 1. That's going to tell you what your shift is going to be. Which is going to be be 1 to the right of your parent function. This is your vertical stretch. Okay, this x minus 1 is your shift. This right here, this is telling you how long it's going to be in your x direction. Okay. And remember, when you work these problem out, you want to make sure that what's in here is an integer. Okay, so for instance, if I had, for example, if I had f of x is equal to 2x, then what you want to do, you want to the distance is going to be 1/2, because in order for this to be an integer, wouldn't that be 1/2? So that means your distance is going to be this is going to be 1/2 each time instead of being 2, because you got to plug in here. See what you got to plug in here to make this equal to an integer. And what's going to plug and make this an integer is 1/2. So your x direction is going to be cut in half, because you're going to get to your y twice as fast. So if you're going to get to your y twice as fast, you're only going half the distance. If you look in your lesson 21, I give you an example to show you how to do that. Okay. All right. So let's look at number 21. All right. So 21, this is your piecewise function. Because they don't want the whole function. They just want a piece of it. All right. So they both equal f of x. So basically, when you see something like this, let me show you. So when we have x plus 4 squared, and you have, what was the absolute value of x minus 3? And so they give you x is going to be less than, or what, -3, and x is greater than 3. I guess I should have wrote this smaller. So basically what they're saying is f of x is equal to x plus 4 squared. Okay, so you want to graph this, but you only want the values for x is less than a -3. Okay, so what you want to do is come here and pick some points. So we're going to do it separately like I did on your answer key. So the only thing you want is everything that's going to be -3 and less. Okay, so I'm going to use do -6, -5, -4, -3. So it's okay for you to use these numbers by 1, because these are whole numbers and this is squared. Okay, so if I use, and so I could keep going to -7, -8, -9, but we can draw a line to let us know that it's an infinite direction. Okay, so if we plug in -6, and somebody gonna say, well, Mr. Bray, how you know what points to pick? I know that the highest point I could pick is -3, and I have to pick answers below that. All right, well, I know I need to pick some past -4, because if I plug -4, this is 0. Remember, this is a quadratic function, and this is a +1. So that means since a is positive, remember this is a. If a is positive, remember we said if a is positive, that's your attitude. If you have a positive attitude, are you smiling or frowning? So we know that we're frowning. So we know this function has to look like this. So since this is also positive, so this is +1. So this right here is also a. It's positive. So if that's positive, you got a positive attitude, you're smiling. But remember, The absolute value function is a v. Your quadratic function is a u. They both have a vertex. So this vertex is the minimum point for both. So we're going to do it separately. So we're going to use -6. So -6 plus 4 squared. So that's a -2 squared. We know that equals to 4, right? So if we do a -5 plus 4 squared, we know that that's going to be a -1 squared, which is 1. -4 squared is 0. -3 plus 4 equals just what, 1? All right. So what we want to do is come over here and graph this one. So if I do, so let's do this. Hold on. Because most of my points are going to be negative. All right, so I'm going to come here. All right. So if I go -6, that's going to give me what? 4. So -6, 4 is right here. Well, I'm going to use -5. Let's do -5. -5, 1 is right here. And -6 is going to be 4. It's going to be right here. And then what we have, -4 is 0. -3 is 1. So since it's less than or equal to, so this is included. So when we graph it, remember it should be a u if it's quadratic. So that's the only thing we want, just a piece of it. We don't want the whole entire graph. We just want a specific part of the graph. And so since this goes on to -infinity, we're just going to put an arrow to let us know that this keeps going. Now, we got to find the answers for the absolute value of, what can I put this? Okay, so where can I work it out? Well, I'm gonna work it out right here. Okay, so we're gonna do was it x minus 3? All right, so we're gonna make our order pair here. And they told us that x has to be greater than 3. All right, so we're gonna plug in 3 because that's where it's gonna be open. Okay, so we put 3, that'll be 0. So 3, 0 is going to be right here. All right, now we're gonna plug in what, 4? So then that's the absolute value of, oh, well, I guess I can do this. 3 minus 3 equals 0. So we got 4 minus 3, that equals 1. So we got 4. Oh, what am I doing? What am I doing? Is that -3? Oh, this is -3. My bad. So this -3, -2, -1. Got to get my life together. Okay, so if I put in, so that should be -3. So that should be 6. I'm sorry. So that should be 6. So a -3, 6. Let me do it over here. Sorry for that. I'm going to get my life together one day. Yeah. All right. I'm joking. My life is fine. Greater than -3. So we have x is greater than -3. All right. So we're going to plug in x, y, -3, -2, -1, 0. All right. So we have -3 -3, and that's going to give us 6, right? So a -3, 6. Remember, it has to be open here because it's greater than. Now we're going to plug in -2. So -2 minus 3, that's going to give us 5. So -2, 5 is right here. Then a -1, that'll give us 4. Then 0, give us 3. Then we're going to plug in 1. Give us 2. Then we'll go down to here, 0. 0. Oh, sorry. 0 is 2. What did I do? Okay, so -2 is 5. -1 is 4. 0 is 3. A 1 is 2. 2 is 1. 3 is 0. Then if I go out to 4, it looks like this. So that's your graph. All right. So the reason why I should have went past 3, but like I said, I have it on the answer key because I know if I plug in 3, that's 0, and that's going to be the vertex. So that's going to be, so that this would be 3, 0. But I need to go past that. So this is actually 4. And so so you're only taking a piece of it. So this is a piece of the quadratic x plus 4 squared. This right here is the function, the absolute value. So this is the quadratic function. And this is your absolute value. And you only want a piece of it. So you restrict it for your quadratic. You restrict it to x is less than or equal to -3, which is -3 has to be included. Then your restrictions on your absolute value function, x has to be greater than -3. Remember, we need to put this in here to see that it's open there. Then you're going to plug in your value. And your restrictions of this, that They only want to see your value for the absolute value function that's going to be greater than -3, which is this right here. All right, so if that is it, we're done. Okay, so what we're going to do is we need to take a quiz on some piecewise functions. All right, so I'm going to just do the even problems for here, and I'm also going to give you some piecewise functions to do and some absolute value functions. So the even problems and give you some piecewise functions and a couple of absolute value functions. And so we'll do that quiz tomorrow. Then the test will be tomorrow evening. No, not tomorrow evening. What's the day? Yeah, tomorrow evening. The quiz will be short. All right, so we're good. All right, I will put the stuff on the blog because I have to teach my AP Stat class. I won't be done with them to about 1:30, maybe 2 o'clock. And so just be looking out after 2 o'clock for the blog. Okay. All right. I'm not going nowhere. What's your question, Mark Charles? What you got? I'm waiting. What you got, man? No, man. The quiz will be tomorrow. I put all that on the blog. And I tell you, so do the even problems on that packet I gave you. Do the even problems on it. We did the odd today. Do the even ones. Just go to the blog this afternoon. Go to the blog and you'll see it. And I'll type exactly what you need. Okay. And for you non-magnet students, please go to the blog and look at those electives so you can have your proper electives next year. All will be revealed on either Remind or the blog today. All right. See y'all later. Any more weights? All right. Thank you, sir. Anybody else? Okay, cool. All right.